We're live. You're listening to Interchain FM, the Cosmos radio station. You're now listening to a new part of the series called the Interchain Jam, where we're syndicating to Cosmos Twitter directly to your feed and to the Interchain YouTube channel if you weren't aware that that exists. Before we get into this episode, the best way that you could support this show is by delegating to Interchain FM stake on your various Cosmos app chains. If you find my content useful, feel free to share this episode. Today, we're here with ZetaChain, and ZetaChain is a layer one, I would say a layer one aggregator. That may not be the best word, and we'll let our guest explain this in more detail today. It's an omni-chain chain of chains, so to speak. And we're speaking with its core developer, Tanmay. I'm going to butcher your name, but it's Tanmay Bhattacharya.
Uh,
How do you pronounce it?
oh, it's a long one. I mean, Tanmay is fine. Yeah,
Perfect. Okay. All right. So, what's your background, Tanmay, and how did you get involved with ZetaChain?
yeah. So I've been part of like the Cosmos space for a while now, about like 4 years, like bunch of projects around using the SDK, using Tendermint, like building ABCI apps. Um, and I got involved with ZetaChain sometime last year around August. And I came across ZetaChain as one of the projects which was trying to build out something which is different from a lot of the other projects out there. And that sort of piqued my interest because there are like right now, if you look at the space, there are quite a few bridges and solutions around that, like how to get tokens from one chain to another. ZetaChain does, maybe we'll talk about this more in this conversation, but ZetaChain does things which are similar, but then again quite different. So that sort of piqued my interest. And yeah, I have been part of this project for like 8, 9 months now.
It's interesting that you say that because when I read through your white paper and looked a little bit at the GitHub, the design looked really familiar, and it reminds me of Blockstream's Liquid Protocol and or TBTC, the way you're attempting to support native Bitcoin
Mhm.
to the best of your abilities with like a multi-sig, right? So how, in your words, is this unique?
Um, right. So I would say it's unique in terms of how it's being used rather than the process. Because, like, if you consider any bridge, a bridge is basically it allows you to pass information from one blockchain to another. When you're doing like token transfers, it's basically information that's going like from one chain to another. What we do is like provide like a generic solution in which in a trustless way you can pass messages from like across chains, right? These messages can be used to do token transfers, which is like a bridge, but other than that it can also be used to execute logic on like other chains. So you could think of it like as a scenario in as like an omni chain contract, right? So you have three components. If you have like three chains connected, and then you have three components which are linked through these interchain bridge, and then you could fire a message from one of these contracts, and these would talk to the contract in like a different chain in a trustless way, and you could execute logic there. It does not always need to be like a token transfer. So I would say it's more of it's a layer below. It's more of a generic solution for message passing, and token transfers can be like a use case for it.
So let me try to explain Zeta Chain in a way that I understood it based on what I've reviewed. Um, so it it seems to build a blockchain whose validators are acting as notaries for what state it observed in its supported chains like Bitcoin, Dogecoin, Ethereum, and ETH Layer 2, Solana, and the chains that you support. But then on the other side, where they're um, controlling the coins on the supported chains, like on Bitcoin, there's a there's a multi-sig that's controlled by the ZetaChain validators, right? So that is how you're basically doing the quote unquote bridging.
Mhm.
Uh, and then on your Cosmos SDK chain, you've allowed for smart contracting on it.
Right.
And so I could only infer that you're designing it in this way because you imagine that an intermediary blockchain that does this will allow for smart contracting by for smart con for the chains that aren't smart contract enabled like Dogecoin or Bitcoin to do that by proxy.
Right. That, yeah, that is one. I mean, that is a great use case. That is one of the, like, the solutions that we provide at ZetaChain. That's because, like, some of these chains do not have smart contracts in themselves, but they still have the notion of, like, holding tokens on a wallet or on an address. And as long as you have that address, and you can have, like, some sort of a multi-sig which owns that address, you could use, like, the native smart contracting that we provide, like, through our, so we have, like, an EVM module running on our Cosmos protocol. And you could deploy smart contracts written in Solidity and still have, like, some level of control over that, like, that multi-sig address, like, however you want to use it. If you want to do token transfers, you could do that.
All right, so the smart contracting capability is enabled through an EVM module that you've plugged in on the Cosmos SDK. Was that the Evmos module?
Yeah, that's correct. Yeah.
Okay, so all right, so Geth, and not it's not Cosmosm enabled.
No,
Right?
not yet. It's not Cosmos anyway.
Got it. So the only smart contracting capability is done through Solidity on ZetaChain.
Yeah.
Got it. All right. So all right, help me define trustless, because then to, to me, trustless doesn't mean multi-sig. That's actually trusted. In fact, that would be that's a similar model as BitGo or any centralized custodian, right?
Um. So yeah. So the trust, when we talk about, like, bridges, it essentially comes from, like, who owns the bridge. And any bridge has, like, two ends to it. One is, like, when you are consuming data. That's basically, like, what you call, like, people observing other chains. And you would have, like, multiple observers who are, like, consuming data from the chains to just to make sure that some tokens, or, like, whatever has been transferred, or just reading information. And the other end is, like, when the information exits. So in our setup, the way we have it is, like, we have validators on the main chain, but then we have two subsets of these validators. One is the observers who are, like, observing the other chain, and the other end is, like, we use TSS signing mechanism, and that's essentially, like, one address which signs off based on, like, a threshold of signatures. And both of these are, like, subsets of the validator set, right? And the trust essentially comes from the fact that they own stake on the main chain. So as long as the stake is through, like, the Zeta token. So as long as as long as the Zeta token has value, the trust in the system comes through that. Like, they have skin in the game on, in, like, terms of being slashed and stuff. So that's where the trust comes from, if that makes sense.
Okay, so it's It has a similar economic model and problem as Liquid and Thorchain, whereby anytime there's more value in the tokens that are being bridged by these validators, then there is value in the total amount staked on ZetaChain. Then you have a problem whereby it's more profitable to steal as a whole, as like a 2/3 set than it is to remain honest. So how does it reconcile those differences?
Um, so okay, the key difference that we have from some of the other chains is basically we don't really lock tokens. So every everything that goes across Zeta chain is in terms of Zeta. So let's just go through like a scenario which might help understand it a bit more. If you are transferring from Ethereum to Binance chain, maybe, right? So you're not send so in a regular like a bridge sort of setup, you would lock ETH on a contract and then you would unlock some tokens on the other chain. But here what we do is like on the Ethereum chain, you would essentially do a swap for your ETH to get Zeta, and that Zeta is then sent to this address where it's locked, and then on the other end we do a swap again and unlock like whatever, like send the tokens over. So the ETH and BNB are never locked basically. The only thing that gets locked is Zeta. And so even if the Zeta is on these contracts, the valuation of Zeta does not depend on it because it's a native token, right? So the valuation of Zeta depends on the activity on the main chain, not on like Ethereum or Binance. So in that way, it provides us like a level of protection. But yeah, it does suffer from like some of the implications because like if the value of Zeta drops, then the whole system does get um, it becomes more complicated to analyze what might happen then.
Right. So that does address the EVM side of things, whereby I assume Zeta has an ERC20 Zeta token on Ethereum, which is why people are able to swap it into Zeta and then lock it into your contract. But what about the other non EVM chains like Bitcoin and Dogecoin, where they don't have that? They don't have smart contracts. So, what would be the Zeta equivalent on those chains that gets locked up?
Right. So for Bitcoin specifically, we have like a separate model in which we follow like the regular sort of bridge format in which BTC does get locked. But for other chains which are EVM compatible, we would have like ERC20 pools of like whatever dexes exist on that chain. So just for an example, maybe Uniswap on ETH, and there would be a counterpart of it in Binance chain or like any other chain that we support. So we would have like pools there, and to add to it, there is we also have like on our EVM chain, like the Zeta EVM, we have a set of pools. Um, we have like a DEX running. It's not super deep, but we essentially use that to calculate like the gas prices because when you're going like across chains you would need to, and since the transfer is happening in terms of Zeta, you would need to know like what is the value of Zeta compared to like the incoming token and the outgoing token. And we don't plan not to query like other chains, rather than use our own liquidity pools and get the price from there.
All right. So help me understand the attack vectors for locking up Bitcoin again, because we're talking about the most valuable coin that exists in crypto, Bitcoin. So even though they can't equivocate for the EVM tokens, there's huge incentive to steal Bitcoin if what they could do is All right. So what if I lose a couple of Zeta tokens if it means that I gain some Bitcoin? Let's let's talk about that edge cases there.
Yeah, so that really depends on the value of, I mean, that's what you mentioned earlier as well. It depends on the value of the value of the total stakes that are in terms of like US dollar maybe compared to the total value of locked BTC in terms of US dollar. And I guess that's true for any sort of lock and mint setup, right? It's there's like that's just like a
Yeah,
problem
absolutely.
that we live with. And the the only real solution is for, I mean, for us it's like as long as the value of the total zeta is more, it's we are in a comfortable spot. But when it is not, that's, I mean, that's a problem that I guess everyone has to deal with.
Yeah, I mean it's a problem that TBC attempted to solve in other wrapped Bitcoin solutions, and right now what's currently available, like the best solution that we have in the industry, is just WBTC in a completely trusted model, whereby you're falling back on um, BitGo's reputation that they're not going to steal from you, and that they're regulated in meat space. But for something like this, I mean, I don't pretend like I have the solutions, but to me, it sounds like ZetaChain could really benefit from using interchain security or some kind of mesh security model with other blockchains that could potentially augment the total value staked, thereby total value slashable in the event that your validator set decides to equivocate. If there's a black swan event where, and this has happened at least 3 times in the past, year and a half, right, where we see that the value of altcoins have dropped by 90% compared to its all-time high, whereas Bitcoin only dropped 50%. So in that scenario, the EV of stealing locked Bitcoin in this paradigm is going to be higher than whatever is is staked on the other side, on the counterparty chain, right? So I mean that's the easy answer that I would see where Zeta Chain could have more value locked up than it currently has with just the Zeta token, especially if it's a nascent chain.
Yeah, definitely. So like the total, I mean, even if you consider the total value locked up in terms of, so the thing is like the reason we would prefer the total value to be locked up in terms of zeta is because all our transfers are in terms of zeta, like in the non BTC chains, like if you consider all the EVM chains that we connect to. So since all the value, like all the tokens that are being transferred on the native chain are zeta, it's just preferable for us to have like more zeta locked up compared to any other tokens, because if we have more tokens locked up, that sort of increases our chance, like it is just potential another potential attack vector which we don't want to really deal with. So as long as the valuation of the zeta is high enough, um, we would not be compromised. But yeah, having like the total amount of tokens locked up on the native chain is definitely more helpful.
Right. Well, then let's talk about the tokenomics so that we could better understand how much value is estimated to be locked up at Genesis so that people could feel relatively secure locking up Bitcoin on the Bitcoin chain to mint it into, tradable assets on Cosmos.
Right. So tokenomics on our chain basically looks like we have a couple of ways in which you could use the Zeta. Uh, so A, right now all the Zeta is through ERC20 and you would need to bridge it over. Like once we go live, you need to bridge it over and get like the native version of it. once you do that, there are ways like you could stake. That's the simplest solution. You could delegate. You could add it to the one of the liquidity pools that exist on like the native chain. And on top of that, right now we are really pushing for like a larger developer ecosystem to go on top of like the Zeta EVM so that people can write D apps and it and make it really easy for them to write like these cross-chain D apps, right? So if you considering the EVM chains that are connected to ZetaChain, you could essentially write like one Solidity smart contract. And since all of these chains like run Solidity, you could deploy these in like the multiple chains, and these can then connect with each other through the message passing mechanism, and that would lead to like super interesting use cases in terms of like cross chain NFTs. And I mean it's limitless on what you can do with it, like even like dexes which live on the main chain but can do like cross chain swaps, that sort of thing. And once you have like a huge developer ecosystem and like dApps running, that sort of drives the tokenomics. Like if you have more usability on the Zeta EVM, uh, you could use those apps to lock tokens as well.
Okay, so Zeta, there were multiple aspects about this project that stood out to me. One of them, which we touched on, which is your TBTC like solution for Cosmos. But the other one is that because you have some kind of general message passing solution here, it sounds very similar to the direction that Axelar is taking. So, in your mind, how did the two differ? I mean, so the interesting innovation that you kind of alluded to with what people could do with something like a general message passing protocol on top of a bridge like layer one, like this, like an omni chain layer one, is you could do really interesting optimized routing for trading of assets that would otherwise abstract away 5 steps into one for the user. And that's exactly what Squid Router has done on Axelar. So uh, I'm interested to understand how this architecture is different from Axelar or similar.
Right. So I mean, I do not know the nitty-gritty details of the Axelar infrastructure, but from what I do understand, there are a lot of parallels. It's very similar. Like they have a message passing layer as well, and they have certain level of automations to at the protocol level to like deploy contracts in multiple chains and even like upgrade contracts, which are some of the things that we are doing or we are planning to do. So there are a lot of parallels. um, we do have like the signing mechanism, which might be slightly different from what they have, because we use like the threshold signature scheme, which essentially allows which makes it cheaper on the outbound chain because there is just one transaction going out instead of like multiple votes. So if like the prices of like the outbound gas token does shoot up, the TSS setup would be a bit cheaper. Um, and even like considering like the number of outbound signers, right? So if you would essentially want like a larger signing set to make it more decentralized. The thing is like the if the signing set is larger, that means like that many transactions going out. So that increases the cost of like an outbound transaction. But if you have just like one transaction, irrespective of how many signers you have, you save quite a bit of money there. So that's maybe one of the differences.
Eh, and help me understand TSS a little bit better as someone who's more naive in terms of her understanding of cryptography. So how is threshold signature scheme different or similar to BLS? Like a or
So yeah, so in essence, what TSS really provides us is, like I mentioned, like it provides us like this one address which can be used to sign these transactions. And the TSS that we have is like created through a keygen ceremony that all the outgoing signers really agree upon, and all of these signers have their own like share of the private key, which
Yeah,
they
each of them has a shard,
yeah,
and then after a certain threshold or quorum of them sign, then you create a one key that could sign.
correct, yeah. And and essentially, like, even if you have that one key, you would need like a certain subset of this set to be online to sign that key at one point. Yeah.
Okay,
and,
got it.
and our implementation is in a way that the TSS signers have their own sort of network, which is independent of the blockchain network. So the TSS signing can really happen in its own P2P network, and it does not have to slow down the blockchain because it doesn't. There are no blockchain transactions for it, so it's it can process irrespective of like what's going on in the blockchain. So that sort of helps with the throughput as well.
Okay, off chain signing.
Yeah, they have their own P2P network. They don't need the blockchain consensus for their trust
Okay,
because yeah.
so is this where they're signing off chain for managing all of your multi-sigs? I mean, all of their
Yeah.
multi-sigs on Bitcoin,
Yeah.
on ETH, any of the ETH rollups, Solana, any of your supported chains. That's what's happening.
I didn't get the question.
So I was just going down the list of supported chains that
Hmm.
ZetaChain supports, and imagining that this off-chain um, peer-to-peer network where they're uh, putting shards together to make a key are managing all of the supported chains for Bitcoin, Dogecoin, and Solana, and all these supported chains.
Right. Yeah. That's how like all the outbounds are signed through like the TSS signers, and we can have like different signers depending on the chain, and also the signing set depending on how on the economics of the chain itself. So if you have like a major outbound chain, like something which is like the price is higher, something like ETH, you would essentially want to have like a higher, like a larger signing set, because to make it more decentralized. But something with like a lower value can have like a smaller signing set. And so, like, again, this helps with the throughput. Like it makes, so you essentially don't need to depend on like a centralized set of configuration to have like different throughputs for different network, and these transactions can happen parallelly.
Okay, how is this Zeta chain different from Thorchain's model and how they tried to do, uh, quote unquote, native Bitcoin trades into Cosmos?
um Again, I am not really super clear on like the Thorchain model, but from what I do understand, it does have like a lot of parallels again. So I do believe like Thorchain has the TSS signing as well, and they are bridging over assets from like EVM chains onto Cosmos. Uh, I don't really know whether they are connected over IBC, which we aren't right now. We are just like compatible with EVM.
Okay. Are there plans to open up IBC connections so the rest of the Cosmos can benefit from a ZBTC? I guess.
Yeah, definitely. So IBC has been on our radar for a while now, and we would definitely have like IBC integration at some point. Um, what we need to sort of finalize is like the smart contract layer to use, because right now it's mostly EVM and like Solidity. If we have IBC, we would definitely want to leverage Cosm as well, because it's a really powerful tool, and I feel like Cosm can be leveraged for a lot of these interchain modules as well that we have, like removing stuff from like the protocol level and moving it in the smart contract level, which is something that we have been thinking of. But yeah, not until like this, the mainnet launch that we are planning in Q2, but definitely on the radar.
Got it. All right. So, in your words, what's the killer use case of ZetaChain?
What's the use case? So
The killer
Zeta,
use case.
killer use case. I that's a really difficult question to answer. But I would say like anything which is cross chain and can leverage from the message passing layer. So I would say like something like a cross chain NFT would be really cool if someone can, if a D app developer can do that. That would be something that's really cool to see.
I want to ask you a philosophical question about this because, unfortunately, I didn't get to record this, but after my interview with Ilya Poloshkin from Near, he actually made a really great argument for why you wouldn't want cross chain NFTs. And the reason for that is because if you move an NFT across chain to a different ecosystem, basically, you lose all the fundamental properties of the NFT in the first place. So you wouldn't want to do that. What you'd want to do is to be able to control an account from the host chain, like let's say near to where to another chain where the NFT is like to the canonical chain for that
Mhm.
NFT on Ethereum, for example. And you just want to have like sort of interchain accounts like model between ecosystems to control an NFT in its host chain and never move it outside of that chain. What do you think of that?
Yeah, that's actually a great point. And I remember having a discussion along the same lines at one point. And the the conclusion that we sort of reached with that is we do agree with the proposition, like we should not move the like the value of the asset across chains. But even if you're moving the token, it doesn't mean the value moves as long as you control where the token is being exchanged. So if you are selling an NFT, that should happen on the main chain, but you can still transfer it to another chain, transfer to a different address. But as long as the selling and buying is controlled on the main chain, you essentially you control the value of it.
Right. So, I mean, one visceral example I could use if we're going to use the like a physical world analogy. So, imagine there's two houses, and one house is in the United States. It's a single family home. It's got a garden and a pool, and another house is in Indonesia, and it's some open air villa with a pool and some like exotic butterflies or whatever. Um, if you're able to digitally copy the Indonesian house, the Indonesian villa into the United States, is it still the same? So I mean, you've injected fungibility into something that's supposed to be non-fungible. Uh, so I
Yeah.
think that this is to Ilya's point that it loses the non-fungibility properties that it originally had into something that's pretty much fungible.
Yeah, I mean, using the same example. So if you have the Indonesian house and if you consider the value of the Indonesian house in terms of like a global currency. Let's just take like US dollar, I mean, right now as like this currency, and the valuation of the house in the States is, I mean, irrespective of what the house is like and what the features it has, the valuation might be, the house in the States might be more, and the Indonesian house might be less. And that's why you cannot like somehow copy this over here because the value is different. But the thing is, you could do that as long as you make sure that whenever you are selling this house, that sale happens in Indonesia. So as long as you are selling it in like the currency in Indonesia, in essence, it should be fine. I mean, although none of it can really happen, but if we are like thinking of a hypothetical situation.
Hmm. Right. And this is exactly why I want to bring Ilya back to have a debate with somebody who's on the other end of of the argument. All right. So housekeeping. Can you give us an idea about milestones? You alluded to mainnet happening in Q2. Is there other news that people could look forward to?
Um, yeah, I mean, this is something that I am not really super familiar with from the marketing side of things, but like we do have public forums and stuff for announcements. The mainnet is planned for Q2 of this year. We also have like a big grants program which we are kicking off. I think it got kicked off today, and that's basically to leverage to allow developers to leverage like the EVM side of things that we have, build their dApps, and start using the message passing layer to come up with like interesting solutions. And we are sort of giving grants to anyone who's interested, as long as they have like a good solution and something which really works.
So, how long has ZetaChain been in development between the start to mainnet launch?
um we have definitely been working on it for a year. I would say more than that. So I have been involved with ZetaChain for a year now, and it was in development before that. So I would say a year and a half, 2 years, I guess.
Right. So, can you speak to the original motivation for doing sorry, for launching a Zeta chain with the Cosmos stack?
Um, so I would say one of the original motivations is the fact that Cosmos in itself provides a lot of these inbuilt systems which you can use to develop like a app layer, right? And some of these things like such as staking and stuff like that come as parts of like modules which are already developed, which you can just use as the base layer and then start developing your application on top of that, which is super cool. And also like the high amount of throughput that the Tendermint consensus provides, that is also something that is beneficial for like a cross-chain solution like us. So these were like kind of the initial motivations, I would say.
Okay. Is there an incentivized testnet that people could participate in?
Yeah, so we are planning to launch an incentivized testnet soon, and we have like certain like levels of tasks and stuff for people to do and get into it, get to know like what ZetaChain is about, how to use it, what it's good for, and things like that. So yeah, that's coming up.
What's the prize amount?
Um, I honestly don't know. I don't know like the specifics of it, but again, I mean, all of it would be announced pretty soon.
Okay.
Yeah.
Yeah, that's very exciting. What exactly are you trying to obtain with an incentivized testnet?
Couple of things really. The first would be like to attract developers, to get them to have like a basic understanding of how to do like cross-chain dApps and things like that. Then there is also the task of like, since it's a test net and you don't have like actual tokens going across, it would be like a good playground for us to see like how things would behave, and there might be some use cases which we might have missed and some stuff which we can fix and improve and stuff like that. We are planning to have this testnet running for a while so that it can act like as a common ground between developers and us, so that both of us can sort of help each other out. They would get to know like what the chain is about, we would get to know like what are the things that they would really want, which we can't, I mean, we can figure out some of the things, but until unless someone really starts using it excessively, we won't really know, what are the real use cases and how do they need help in terms of operations and stuff like that.
Hmm. Got it. So we've got a question from the audience. FMS NFT asks, interesting. If I, as a creator, cannot sell my NFT from Stargaze on OpenSea or OmniFlix, what's the benefit of cross-chain NFTs? I think accessing a bigger market would be cool.
Yeah, that is a good question. So I would say like one of the use cases it would be like transferring from one address to another. So you could transfer tokens and then you could exchange your NFTs for other things, but you would have to come back to the original network to sort of sell it and exchange it for like currency in that term. Yeah.
And there's a follow up. He asks, or would I sell it on OpenSea for stars?
Um, I actually don't know what stars are, but if
It's
that's
the token for
yeah.
Stargaze network.
Oh, okay. So yeah, you could exchange it for stars as long as it's on the same network, as it's the same chain.
The ArtLink says, I suppose you could mint derivative NFTs on the other chains and track their royalties back to the OG NFT.
Yeah, that is another solution that we were thinking as well. So, but the thing, what happens is like when you have like multiple chains, maintaining these relationships between like the OG NFT and the derivatives then becomes like a state in itself. So right now, when you have an NFT, it's essentially like a count of like this ID is owned by this address. And now when you have something like this, you would have like one more column in that on that sheet which says like this ID is this address, and then it's linked to this other column which has one more address. So it's just like high bigger state, more maintenance, which is kind of the reason that we did not want to go. I mean, we are not discarding it completely, but that's one of the concerns that we had.
It sounds highly complex. And what would you do with that? Like, I imagine it would be something similar to the derivatives of, mortgages or something like that.
Yeah, it's actually very similar to that. And I mean, there are things that you can do, and there are things that you need to do, right? And I think this is like a gray line between all of it, because I mean, you could have like as complicated a system as you want to, but then on the flip side, it's like the more complicated systems that you have, the more difficult it becomes it like to secure it and maintain it and things like that. So
And it's
yeah,
greater attack surface, not to mention.
yeah, exactly.
We've seen how daisy chain derivatives in lending markets have lent themselves to um, opening up bigger attack surfaces.
Yeah, definitely. And like the blockchain space in itself, it's there are still like new ideas coming across and everything like growing and stuff like that. I feel like we would definitely have like better levels of understanding of how all of these things would work in the near future, but you need to go like step by step, get things right first, and then go into like more complicated systems.
Sure. And keep it simple, stupid. Let's go with that. Complexity lends itself to greater attack. I think that's been the truth. Um, I don't necessarily think that more complex systems lends itself to better solutions necessarily. So, thank you, Tanmay. How can people find you?
Um, like I can share my LinkedIn and stuff. I'm not super active on Twitter, which is super weird for being in the crypto space. But yeah, LinkedIn, GitHub, that's the best place to find me.
Okay, great. And thanks for coming on to Entertain FM on the Interchain Jam series. And for those of you listening in live or listening to us later, congrats for listening. Even while we're in a bear market, may you prosper from the alpha that you have derived from this episode and become rich in knowledge and in wealth. Bye, guys.
Thanks for having me.